Bosons Botany welcomes you all, and today's topic is pigments or pigments found in chloroplast, and the first pigment is chlorophyll. There are three main types of chlorophyll, and these are chlorophyll A, B, and C. Chlorophyll A and B are very important, so their formulae are chlorophyll A C55 H72O5 N4 Mg, chlorophyll B C55 H70O6 N4 Mg, and chlorophyll C C35 H12O6 N4 Mg. And chlorophyll A and chlorophyll B, as I have already said, that these two are very important, so I have drawn their structures. But before I define them, I would like to highlight few points written here. First, chlorophyll as a molecule in general is water insoluble and asymmetric in nature, or asymmetric molecule. As you can see, there is no symmetry followed in both the structures, so it is asymmetric in nature. Second point, porphyrin hydrophilic head of 4 substituted pyrrolic rings present around magnesium ion, which is complex with 4 nitrogen atoms, hence tetrapyrrols are present. This means if you notice this particular diagram, there are 4 pyrrole rings, 1, 2, 3, 4, and pyrrole ring is basically an aromatic heterocyclic organic compound which is a 5-membered ring having the formula C4H4NH. It is heterocyclic because there is a nitrogen atom. Therefore, it is heterocyclic in nature. So, there are 4 pyrrole rings present, bonded or surrounding magnesium ion, and therefore it is tetrapyrrole in nature, or chlorophyll molecule is a tetrapyrrole structure. The third point is a phytol tail is present, which is hydrophobic in nature, and this phytol tail is known as isoprenoid chain. Here, as you can see, there are 2 long chains of hydrocarbon. These are hydrophobic in nature, that is water insoluble, and this particular region or this particular part is known as isoprenoid chain, and it is hydrophobic in nature, and it is also known as phytol tail because long structures, these are long structures and resembling like a tail, and it is hydrophobic in nature, that is water insoluble. So this particular part above the phytol tail is water soluble, and the lower portion, which is known as the phytol tail, is hydrophobic in nature or water insoluble. Now if I come to the diagram, both the diagrams are similar without any significant difference, but there is one important point, that is, if you notice the second pyrrole ring in case of chlorophyll A as well as in chlorophyll B, the second pyrrole ring, the third carbon, I have already numbered the carbons here, 1, 2, 3, 4, 5, 6, 7 and 8. Similarly here also 1, 2, 3, 4, 5, 6, 7 and 8. If you notice the second pyrrole ring and the third carbon, in case of chlorophyll A, the third carbon and the second pyrrole ring has a methyl group, that is CH3 group, methyl group. But in case of chlorophyll B, on the similar position, that is, the position is same, the placement is same, but the group is different. Here the group is aldehyde, that is CHO or C double bond OH, aldehyde group. So in case of chlorophyll A, there is a methyl group, that is CH3, and in case of chlorophyll B, there is an aldehyde group or CHO group. This is the main difference and very often asked in many of the question papers. The structures are similar without any difference, but the main difference is presence of methyl group in case of chlorophyll A at carbon 3 position and second pyrrole ring, and an aldehyde group in case of chlorophyll B at carbon 3 and second pyrrole ring. So these are the 2 main structures. You should not remember the structures, but please remember the position of these 2 functional groups or these 2 substituents, which are very important. And also remember that there are 4 pyrrole rings and therefore known as tetrapyrrole ring. and presence of magnesium ion. Chlorophyll molecule is having the metal which is magnesium or magnesium ion. So often asked which metal is present in chlorophyll molecule, so your answer will be magnesium or magnesium ion. So in my next video I will tell you the other two types of pigments found in chloroplast apart from chlorophyll molecule. Thank you.